acknowledge the traditional owners of Lutruwita, Tasmania, the Muwinina and Palawa people. They are the original and traditional custodians of the land we are broadcasting from today in Nipaluna, Hobart. We pay our deepest respects to their elders past, present and emerging, and those who did not make elder status. We acknowledge the deep history of storytelling, knowledge sharing and caring for land. So I'm Professor Adele Holloway. I'm Acting Head of the Tasmanian School of Medicine, and I'm a biomedical scientist and educator and an alumni of the University of Tasmania. This annual event honours the memory of Professor Arthur Cobbold. Whether you're joining us from the comfort of your living room or you've stepped out to socialise at a medical sciences precinct tonight, all of us now are actively participating in a legacy first established in 1964 when Professor Cobbold arrived as a Professor of Physiology at the University of Tasmania. Our Island of Ideas program is hosting this talk, and it upholds a valued university tradition upheld by leaders like Professor Cobbold, where we connect with our community to discuss issues, opportunities and challenges that we collectively face, where we share ideas, research and insights, both from the university, the wider community and further afield. These conversations are an important part of the university's role. Connection, collegiality and community date back to our founding in the late 19th century and remain core to our values. So to start this evening, I'd like to introduce Dr. Rob Walters, the late Professor Cobbold's student, one of Hobart's most experienced and respected general practitioners, to provide us with some insights into this annual event and its namesake. So thank you, Rob.
Thank you very much and welcome everybody. The 14th lecture, I was amazed when I had a look earlier this evening and looked over the subjects that we've covered and thought back to those 15 years ago when Elizabeth Cobbold, Arthur's wife, and I sat down and talked about this concept. Some fantastic topics have been covered, and I'm sure, Tim, we're going to thoroughly enjoy tonight's presentation. Before we do that though, a little bit about my mentor, Arthur Frederick Cobbold. As was said, I'm one of his students, and he was the Dean of Medicine throughout my medical school days. Arthur was born in Bethnal Green, which is in East London, in 2020. He was educated by the Jesuits and gives them credit for his interest in the classics, theology, and public oratory, and talk a little bit more about that public oratory later on. He started out initially after schooling in accountancy, but that was not of interest to Arthur. And then Second World War intervened, and so he enlisted in 1939 in the military, was based in Southampton when it was bombed and was quite severely injured and was invalided out of the military in 1942. He stayed in the Southampton area though and studied at the Southampton University, where he studied science, and that's where he started to get an interest in science. He taught in Lincolnshire and then did honours in chemistry and physiology. And it was this physiology that led him to becoming a lecturer and later going to Nottingham University, where he studied physiology, and he did some research and a PhD later at St Thomas's, that eminent hospital in London. He then became a senior lecturer and studied under Henry Bancroft, a very eminent physiologist, and did some groundbreaking research into the control of blood flow and into the control of vascular systems in various parts of the body. Whilst he was at Nottingham University, he developed an interest in politics. And initially at a local council level, so he became a councillor in the Kent County Council, and then became chairman of the Bexley Conservative Party and helped their local member, one Edward Heath, rise to power. And as you would know, Edward Heath, in fact, became Prime Minister of the country. It was even mooted at one stage that Arthur was destined for a career in politics and as a potential candidate. But then Tasmania intervened. 1964, Cyril Barnett was the foundation dean of the medical school, and he enticed Arthur and his family to come out to Tasmania to be the foundation professor of physiology. They were housed in, I don't know whether many of you remember the old World War II huts down near the rugby grounds and the footy grounds at the university there. Amenities were very meagre. The resources were poor. It was underfunded. He would wax lyrical about the toughness of those days. And initially, it was very difficult to get the medical school up and running. He was, however, instrumental in the progress of the medical school, and certainly in the move to the clinical school down on Collins Street, attached to the Royal Hobart Hospital. Arthur was finally appointed as Dean in 1969, a position he held for 13 years. Arthur didn't stick to the university and to the medical school, however. He was on the Royal Hobart Hospital Board and chaired that board. And through that, he influenced health policy quite considerably, and in fact was awarded an AM for his efforts in medical administration and medical education, and certainly he was very influential in policy related to the Royal Hobart Hospital. His favourite award he received was an honorary doctorate from the University of Tasmania as an honorary doctorate in medicine. And he was enormously proud of that. He got that in the year 2000. There are people who influence your life, and I think I can think of 2 or 3 teachers that I've had that have been enormously influential in my life, and I don't think we tell them enough. And I think we should perhaps take the time to go and tell them. Arthur was certainly one of those for me. He had a laconic sense of humour. He was a man of few words, but he was much sought after for after-dinner speeches. He had an enormous intelligence network throughout the med school, where he knew exactly who was who and who was doing what to whom and who was doing things they shouldn't be. And sure enough, they would get mentioned in that medical school after-dinner speech, much to the embarrassment often of the perpetrator. He was a man of good humour, good grace, enormously fair, and I remember him as having common sense. When there was an issue, not many people argued with the fact that the common sense prevailed and he was fair, but above all, he had enormous integrity. He loved his classical music, he played the piano, opera, but above all, Arthur Cobbold was a man who made a difference. He was a good man.
Thanks for those lovely words, Rob. As Arthur once did, we remain dedicated to equipping students in the community with the skills and information they need to flourish. The ideas generated in this university focus on solutions for our place, but resonate far past the waters of Bass Strait. We seek to instil in our graduates a sense of the unique place in which they earned their qualification, its opportunities and challenges, and we hope they will take these challenges and be brave enough to imagine and even implement informed solutions for our island and beyond. It's in this tradition that tonight's Cobbold Memorial Lecture is presented by one such graduate, whose work, I'm sure you'll soon agree, embodies such dedication and innovation, reflecting the spirit of our university. Professor Walsh is Professor of Medical Microbiology at the University of Oxford and the Co-Director and Biology Lead for the INEOS Institute of Antimicrobial Research. He has been studying antimicrobial resistance mechanisms for over 25 years. I will leave more for you to discover about Professor Walsh during a special presentation to follow his talk. So to deliver the 2024 Arthur Cobbold Lecture, Antibiotic Armageddon, Do We Have Hope? Please join me and welcome Professor Tim Walsh.
Gosh, the lights are bright. First of all, thank you very much for allowing me to give this lecture, and also for the award I received from UTAS. I have presenting this lecture to colleagues, to friends and family, and also to fellow students that I did my kind of honours or postgraduate diploma in many years ago when I was down here in Hobart. So I'm going to give this lecture, and this lecture was a bit of a challenge really, because, you know, number one is Antibiotic Armageddon. Well, that sounds kind of a bit fatalistic, you know, and then do we have hope? And so my challenge is in the next 40 minutes or hours, and I've got quite a few slides that they told me, but I'm going to try and convey some of our research and what we do in trying to address this problem. So without further ado, we'll go on to the next slide, which hopefully good. As you can see, this is sort of the emblem of University of Oxford, and this is our institute. I have an honorary degree at China Agriculture University. I'm director of Barnard's, and I'll come back to that point later throughout the slide. And here we have two flags, which hopefully most of you will know. The one on the left is Nigerian, and the one on the right is Bangladeshi. And I am advisor to both the Bangladeshi government, or pending that is, but I'm certainly advisor to the Nigerian government as of a few weeks ago. And that is an important distinction to make, as hopefully will be evident later on in my talk. So who am I? Because I think it's kind of important to know, you kind of listen to my accent and you think I'm just a POM and an infiltrator and an interloper, but actually this is me, probably age 1.5, taken in 1965. I was actually born in 1964, when in fact Arthur Cobbold took up being director or lecturer in the medical school. So I was born in the UK, I was born in Bristol, and this is now me, my first year at Rosetta High School in Tasmania, in Hobart. Rosetta High School no longer exists. It's merged with Claremont High to become something else. But my first years in Tasmania were not the easiest, being a young POM, as you might imagine. But it was quite useful for me because I'm dyslexic. And in the UK, they grade the students very earlier on. And I was completely rubbish at spelling, as you might imagine, and reading, but I was rather good at mental maths and mathematics and so on and so forth, and creative writing. So in the UK, they didn't know what to do with me. And so they put me in the middle, as you do, which was spectacularly unhelpful because I got bored at both ends of the subjects. So therefore, in Tasmania, there was a reset. They didn't, in Rosetta back then, they didn't grade you until you were in grade 8 or grade 9. And so that gave me the chance to be a little bit creative. And I'm kind of naturally rebellious, as you will become evident throughout my talk. And therefore, I wasn't particularly sort of prescriptive in when I was given homework to do. But what it did do was to allow me to be creative. And for that, I'm very, very grateful. I went to Elizabeth Matriculation College in 1981 and 1982. And then I, first of all, enrolled in UTAS down the hill in Sandy Bay doing marine biology. And I failed botany. I passed everything else with flying colours, but I failed botany. Clearly, plants didn't move quick enough for me. And so therefore, I then went up to what there was then TSIT. It was going to be called TITS. But rather like most acronyms, they seem to have got it very badly wrong, so they called it TSIT, so the student magazine was called Mammary Lisp, etc. Anyway, I graduated in 1986, And then in 1986, 1987, I started at Royal Hobart Hospital. And essentially, I loved microbiology because all the other disciplines of pathology were actually really quite boring. You put your sample in a machine, it spat out the result, and that was that. But microbiology was very tactile, it was very hands-on, and I kind of liked the discovery of it. But I didn't actually study microbiology at TSIT, so it was a bit of a learning curve. After about a year or two, I got bored with it. So then I spoke to my boss then, and the boss is not my wife who's sitting in the audience, although she could be my boss, but the boss was at Royal Hobart Hospital, said, what do? I want to do like an honours degree. Well, I wasn't allowed to do an honours degree, but I did the equivalent of what they call a postgraduate diploma in immunology and microbiology. I was the first student in UTAS to do this, so nobody had a clue what to do about me. And I didn't have a clue what to do either. So it was a bit of a learning curve going on there. But anyway, I presented a dissertation, and the dissertation was on something called beta-lactamases. And beta-lactamases basically are enzymes produced by bacteria that break down antibiotics. I didn't want to do that subject. I wanted to study virology. But my boss, Richard Tucker at the Royal Hobart Hospital, said, no, you're going to study beta-lactamases. So I suppose I have him to thank for being in Oxford and and all those sorts of things. Anyway, I graduated in 1990. I was then very fortunate enough to have an award by the British government, and I met King Charles. I've met him a few times, and despite all the issues going on in the monarchy at the moment with various health concerns and family, that actually Charles is very interested in environmental pollution and One Health concerns, sustainable planet. He really is, and he's actually very interested in my sort of subject area. And finally, I was awarded my DSc in 2023, photo bombed by my daughters, or at least one of them taking the photograph, and the other one photobombing it. And I got that from the University of Bristol. I would just like to add that I did apply to University of Tasmania for my DSc, but I was a bit of a square peg in a round hole. So in the end, I went to University of Bristol. And it was in fact in Bristol where I was born way back in 1964. And so everything sort of came full circle, really. The thing is, with antimicrobial resistance, you know, what is it? You know, how do you define it? If you're standing in the queue in the supermarket and somebody says to you, what do you do? And you say, well, I study antimicrobial resistance, and you've lost them immediately, you know. So the thing is how do we take that and make it relevant to people? So it's essentially, antimicrobials are viruses, they're protozoas, and they're bacteria. And basically, antibiotic resistance is where you have resistance from the bacteria against a particular drug, okay, an antibiotic. And so it's important to make that distinction. Why is it tricky? Why is it difficult to explain? Because all of you in front of me and those listening online have more bacterial cells in you and on you than you do human cells, by about a ratio of 10 to 1. And you think about the number of bugs in your gut, so every time you go to the toilet and you defecate, you are pushing out, you know, vast billions and trillions sometimes of bacteria. So when you take an antibiotic, you're exposing all your normal flora, which is immense, and just trying to get rid of the pathogen. But you're exposing all your normal flora to that particular antibiotic. And so it's really complicated. And those bugs, by the way, in your gut and in other parts of your body are friendly bacteria. They're there to help you and protect you. But nonetheless, they are exposed as well. Why is it more tricky? Because bacteria are very small. They weigh about 5 picograms. And for those of you who don't know what a picogram is, that's not very much, okay? So when there's a breeze or a wind, the bacteria go everywhere. So for example, when you open that door at the back of the auditorium, the bacteria go everywhere. When you sneeze, the bacteria go everywhere. When you flatulate, the bacteria go everywhere. You know, and so, you know, this is just part of, you know, who we are and our existence with microorganisms. Why is it even more tricky? It's even more tricky because bacteria multiply between every 20 minutes and roughly an hour. 20 minutes under optimal conditions, an hour under suboptimal conditions. You know, human beings, we kind of procreate and we multiply roughly every 20 years or 25 years, whatever. Bacteria have that advantage over us. Every time they multiply, they have the potential of making mutant bacteria, and that means they can become resistant to the antibiotics. But it's worse than that, because bacteria are able to share DNA, and they're able to share DNA at a fantastic rate. And this sharing of DNA involves small circular pieces of DNA, and we call them plasmids. And they basically, as we'll see in a minute in the next slide, they're able to transfer those at a remarkable frequency. So, onto that point, I should also point out, before we go there, I'm actually going to compare COVID to AMR. Because COVID is what everybody in this room is familiar with. I'll give you the UK experience of COVID. We basically went into lockdown in about the middle of March 2020. We started coming out of that probably about a year later when the first vaccines were being wielded out. And then obviously the vaccines were basically staged into priority groups, healthcare workers, elderly, and so on and so forth. But what I've done here is to compare COVID to antimicrobial resistance. How many deaths associated with COVID thus far? And this is from Worldometer data. And it's roughly 6.9 million people have died, and you can argue whether that's attributed to or associated with. With AMR, at the moment, we are 5 million and rising. And that figure by 2040, 2050 will probably go to at least over 10 million, if not somewhere at roughly 16 million from the mathematical modeling we're doing. So basically this means, well, a couple of years' time, it's going to be 3 times COVID year in, year out. Who will be affected? COVID affected the elderly, the very elderly, and also those with comorbidities, those who had obesity, those that basically had respiratory distress, etc. With AMR, antimicrobial resistance, it will be neonates, newborns, children, and women. And often it's not. With AMR, the stigma is usually associated with a female in terms of risk associations, either through childbirth or chronic urinary tract infections, and generally sexual health. How much money will it cost? Well, so far, depending on who you look, but if you look at Reuters and World Bank, it's roughly cost us 12 to 14 trillion US dollars to tackle COVID. AMR in total between now and 2050 will cost us over 100 trillion. So it's going to dwarf what we've actually paid for in terms of COVID. Which countries were affected or will be affected? COVID, it was high-income and middle-income countries. If you think where it started off, it started from Wuhan, and then actually one of the first countries to be hit after China was actually Iran, which most people really haven't fully considered. And then it spread into Italy and then Spain. And there was a particular football match at the San Siro in Milan. It was Real Madrid versus AC Milan. And basically that was the epicenter where you had lots of people shouting, and from there on, COVID went like this all over Europe. But nonetheless, it was high-income countries, middle-income countries, not necessarily low-income countries. With AMR, the burden, the clinical burden, will be low-income countries, as I will show you. Can it be fixed by a simple vaccine? COVID, yes, it can do. And I've put in there vaccine wars because some of the behavior by some of the countries over stockpiling and not sharing was disgraceful, and I'll come back to that point when we talk about UN. AMR, you've got no chance of actually solving this problem with vaccines. Can diagnostics be quickly implemented? We had the lateral flow with COVID, which probably everybody in this room used. With AMR, we simply do not have that, that availability. So I'm going to just talk to you now about conjugation, because it's very important. How do bacteria share DNA? Because this is really the crux in terms of the mechanisms of how AMR spreads. So essentially what we have here is the left on the side, we call this the donor, and this is the recipient. And classically what happens is that you have these small red circles, they go from the donor over to the recipient. This, for those in the room who don't know what that is, this is an agar plate where we grow our bacteria, but we've been hampered by the fact that we've had to grow that bacteria on an agar plate. So essentially what happens is that we make the bacteria together, we put them together, we turn the lights down low, we light some candles, we play some Mozart, we come back in a couple of hours, and hopefully they've actually managed to what we call bacterial sex. But the problem with all of this is that we have to grow the bacteria. If you take all the bacteria on planet Earth and ask the question, how many of those we can grow, it's about 30%. So another 70% of the bacteria we can't grow. We've got no idea what is going on. So in other words, this is really artificial. So one of the things that we've done, and this is the inspiration really of this student of mine, ex-student of mine, she's now in Fuzhou in China, called Chua. What we did was to basically take a plasmid and label the plasmid, and then we went through this system, which we call a non-culturable system. You don't need to read the details. All you need to know is we didn't have to rely on culture for this. And the results that we got were absolutely staggering, because normally with a cultural type of mating, we think that bacterial resistance would spread like this via plasmids, but what we found was that part of the iceberg underneath the waterline. Basically, the diversity of bacteria accepting these plasmids was just massive. And in fact, what we have in microbiology, we basically divide bacteria into two groups, gram-positive and gram-negative, and it completely crossed the gram-negative, gram-positive barrier for the first time ever that we've done that. And what we're now starting to try and understand is that the frequency was much, much higher than what it was, and so our understanding of antimicrobial resistance in terms of plasmid transfer has been completely and utterly, the paradigm has been destroyed. So now what we're doing is using this model and we're applying it to certain things that we are looking at in terms of issues that are going on in the world. So one of the things we're looking at is essentially plastics. And we've basically taken this model and then we've basically exposed that model to different types of plastics and different sizes of plastics. And we found actually that the presence of plastics actually increases the transfer of these plasmids by about 1,000-fold, sometimes 10,000-fold. So the way in which we kind of treat our environment, which we think may not actually have an implication with antimicrobial resistance, certainly does. The other thing too that we've done is to collect soil samples from all over the world, and we've brought them to our friends in Fuzhou, and where we basically ask the question, are there differences between soil samples in East Coast of Africa, South America, Europe, etc. And then what we're doing with them is increasing the temperature to try and simulate climate change. And what we're finding is that actually as you increase the temperature, lo and behold, that you also get an increase in the transfer of resistance. So we're trying to map this to environmental pollution, but also to climate change. So this is kind of one of the problems that we have with antimicrobial resistance. This is kind of what we call a One Health approach. And I was asked to write this article by Nature Microbiology many years ago. And the reason why I was asked to write it is because I got really, really sick and tired of people using this term One Health. So the editor said to me, okay, Tim, well, if you're sick and tired of it, you go and write an article about it and tell us why you're sick and tired of it. And the problem is that One Health can mean anything to, well, everything to anybody. And it's really, really undefined. But essentially, when you think about bacteria, which is, like some flies from Hobart. So anyway, there we are. There's the challenge. So what is this? You should know this. Everybody in the room should know this, because this is the United Nations Sustainable Development Goals. And this is basically where we want to try and project humanity in about the next 20 or 30 years. This is how we assess global health. It's divided up into 17 kind of regions, and you can look at those and look at things like no poverty, gender equality, things that we would all sign up to, and we would all think that was really, really good. And when I look at this, I think roughly 16 of them essentially map to antimicrobial resistance, because they involve human behavior and basically how we use medicines and about global health. So all of them are involved in antimicrobial resistance. You could say, for example, that peace, justice, and strong institutions doesn't. But this next slide is from Gaza, and I could have picked, and this is completely and utterly without politics, I could have picked anything from eastern Ukraine, I could have picked the issue in Sudan at the moment with Khartoum, but I've decided to pick Gaza. And you can see that the infrastructure is broken here. There's no potable water, there's no toilets, there's very little health provision here. And so where you have this sort of falling apart of infrastructure will affect bacteria spread and therefore also antimicrobial resistance. This is a slide from a region in China where we work. And basically about a year and a half ago, no, actually, it wasn't a year and a half ago, it was 9 months ago, this part of China in Zhaojiao, which is just around Beijing, was seriously flooded. And you can imagine that where you have this massive flooding going on is that the bacteria will just spread everywhere. You'll get contamination of fecal matter from humans, from animals into potable water, and people are going to be wading up to their chest and to their neck in fecal material. And that involves basically bacteria that are very seriously resistant to antibiotics. So now on to Oxford and kind of my career in Oxford. I have been around a bit. So I moved from Bristol into Cardiff. And when I was in Cardiff, I did a sabbatical, a short sabbatical in northern Norway. And then we did a sort of a forced sabbatical in the University of Queensland, and then I moved into Oxford. And I moved into Oxford in July 2020. And as I was moving into Oxford in July 2020, this guy here was in contact with a surgeon, an orthopedic surgeon, who contacted me back in February 2020 and said, "We would like to set up an institute and we need a bug guy. And would you like to join?" You know, and what do you say? Well, you can't say no, can you? So this guy here, for those of you who don't know him, his name is Sir Jim Radcliffe, and he is the richest person in the United Kingdom. And he has done a lot of very interesting things. He has bought parts of Botswana and Tanzania for wildlife preservation. He has bought parts of Iceland to preserve for wild salmon. He also basically has taken over the America's Cup Challenge in yachting and funded the British team. And he's done Formula One, he's done Tour de France. You know, he is interested in lots of things. And basically, Jim Radcliffe said, we want to basically tackle the challenge of antimicrobial resistance. So essentially what happened, the conversations went on, and eventually he gave us a lot of money. The money was £100 million. So rather a lot of money. So what do you do with that amount of money? You know, so we decided not to build it put it into a building of bricks and mortar, but actually to put it into people. And we decided to build an institute around here whereby we have different programs, antibiotics only for animal use, overcoming resistance to human antibiotics, and what we call the burden of antimicrobial resistance. There's also communications and engagement. So I'm going to talk very briefly about this one, and this one up here. So antibiotics have been used in animals since its inception, way back in the 1950s. As soon as they were available in humans, we started to use them in animals. Slightly crazy, but it's true. And 70 years later, we haven't actually learnt our lessons. So we still have basically these antibiotics that we use in humans, and I think in Tasmania you still use tetracycline in the salmon farms and elsewhere around the world. And by the way, don't feel too bad about that, because the amount of tetracycline that's used in farming, globally speaking, is 100,000 tons. Okay, rather a lot. As well as really important antibiotics like colistin. These are the figures of where we're going to be. Basically, we have an increased population, poultry production will go up, you can become vegetarian, you can become vegan, but a lot of the rest of the world will want an increased demand for meat, and also antimicrobial usage will go up by about 11%. So we have to try and do something about it. Unfortunately, these are as I said, the antibiotics we use in animals. This is the type of resistance it selects, and that then provides resistance to human antibiotics, to really important drugs like carbapenems, colistin, and tigecycline, of which 2 out of 3 of these are on the WHO reserve list. So we can't keep on doing this. This is just insane. So we have to try and think of ways around this. These are the countries that are mainly the culprits, the ones hotspots in purple. We have North America, we have South America, we have South Asia, we have Southeast Asia, China, and of course we also have Europe. Everyone is to blame, it's a global problem, and so therefore the focus should not be on one particular country. The increase that we see, forecast increase, will mainly come through Asia, but also in terms of volume, overall volume, but actually South America in terms of percentage will also have a rather large increase. The types of antibiotics that will increase, antibiotics, really important antibiotics like tetracycline, penicillins, and also antibiotics like macrolides, which we use to treat human respiratory tract infections. So one of the things that we decided to do was to do a deep dive and find out exactly who produces colistin, which is probably the most important antibiotic we use in human medicine, and to find out exactly where colistin is coming from. And you can see that essentially it mainly comes from China, not exclusively so, but it's interesting that it then is imported into Europe. And Europe has actually banned, through ERMA, European Medicines Agency, and also European Union, banned these drugs from being used in Europe. So what happens is that you have these subsidiaries in Europe, and they repackage them, and then they dump them into Kenya, Nigeria, and South America. So this is a trade, rather nefarious trade, that we exposed in this particular publication here. And this is just some of my team, Umar, Breshna, Rafat, and Saniet, to collect this really interesting data. We also asked the farmers in, for example, Pakistan, Bangladesh, Nigeria, and Kenya, what they were using. Did they know what they were using, and did they have some understanding of resistance? And as you can imagine, the answer was no, 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 no. But this is really exploitation by European countries or companies. So basically, we need to go into a new direction in farming. Vaccines are really, really good, and you can use them in your salmon farms because they do it in Norway, and it's super effective, and there's no real need to use antibiotics. Phages basically are viruses that attack bacteria, and therefore these are now starting to be things seen to be useful in terms of treating chickens and ducks and so on from infections. What we are doing in Oxford is basically trying to find alternative compounds to human antibiotics, and we have this logo called Products Containing No Human Antibiotics, or NHA, and that is where we want to try and be. And I think in the next slide, this is the screening that we do. Again, this is Sir Jim Ratcliffe, who really, really was interested in this and signed up to this. And we go from hit to lead to preclinical candidate. And we're already working on a farm, doing farm trials in China to basically look at these compounds that are not human antibiotics, but hopefully will have the same effect in protecting the chicken from getting a disease. And those are continuing. I'm now going to talk very quickly about the burden of antimicrobial resistance, which involves a lot of clinical work, particularly in Africa. So these are just some of the figures that I mentioned before. This is where we are in 2019. Basically, 5.3 million people die of AMR every year. The reason why we don't hear about it in places like Tasmania or overall in Australia is because the burden of this is always in low-income country. And remember that this figure is not too far away from the total number of people since beginning, well, you could argue the end of 2019 that have died from COVID. The biggest countries that are affected, first of all, Sub-Saharan Africa, then South Asia. And these acronyms is low respiratory tract infections. And this one, which I'm really, is nearly all my research, is BSI, which stands for bloodstream infections. We can just call this sepsis, and I will call this sepsis from here on in. This study, this is just a diagram from this particular study that actually shows that or the African countries are the most affected. And there are lots of reasons for that I'll go into in a moment. This is the first study that we're doing in Oxford, and we call this BALANCE. And BALANCE essentially is understanding both the clinical burden of antimicrobial resistance but also the economic burden. So in Tasmania, you have your system of basically deferment of cost and insurance and where you get your money from after you've been to hospital. And it's all laid out for you and it's all straightforward. In many of the countries that we work in, it's not straightforward, and the deferment is often not passed to the patient. So the patient will not only have to pay for the antibiotic or the drugs, they will also have to pay for the bed care as well. Can they afford it? No. So what happens? And this is a really important question, because if they don't get the antibiotic or they don't get appropriate antibiotics, and then obviously the infection is going to get worse, and that will increase morbidity and it will increase mortality. So understanding the economic factors on this is super, super important. And sadly, very few people have done that. And I'll come and talk about the United Nations in a moment. This is really my baby, not that one, but the study's my baby. And we call this Barnard's, and these are the countries where we work. You'll notice that most of them are African countries. We also work in Bangladesh and we work in Pakistan. These is a study whereby we took roughly 1,200 isolates from mainly, again, Pakistan, Bangladesh, and Africa. And the ones in red are basically where you have lots of resistance. The reason why I'm showing you this is because the WHO would say that in order to treat a neonate, you should use gentamicin and ampicillin. And that is your first line therapy. And you can see from this that if you do that, you have 65% resistance. And that's insane. You know, it's insane that we should be advocating drugs where resistance is very high. The problem that you have in so many hospitals where we work is that the hospitals can't afford those antibiotics, and getting access into those hospitals is very, very difficult. This is another study, neonatal unit from South Africa. Again, the red is resistant, and you can see with really good drugs like amikacin, we essentially only have more or less 50% efficacy, and with a lot of these other antibiotics, it's over 80%. And that is why mortality is so high. So high, and these are just some of the mortality rates that we have, again, in some of the hospitals where we work. In Desi, in northern Ethiopia, it's 27%. As high in Karachi, and this is called National Institute of Child Health in Karachi, is 28%. In PIMS, in the capital, 40%. And even in places like Mozambique, you can see that it's 40%. So it's ridiculously high. We're losing 2 out of 5 newborns, usually due to infections. So what can we do? Well, one of the things that we can do is to try and understand the economics around all of this, as I've already mentioned. This was from the previous study. In fact, I think the paper, this is the article that we published in Lancet. And what we tried to understand was who actually pays for the antibiotic. This is the cost of the antibiotic here. And we just simply asked the question, does antibiotic cost influence accessibility? Yes, 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 yes. In other words, the baby does not get the right antibiotic because the hospital can't afford it, and neither can the patient. And therefore, access to appropriate antibiotics is really important. I'm now going to just kind of segue a little bit and give you a very pictorial kind of walk or journey through some of the sites where we work. And the first one is this one here called Kanu. And in fact, you'll probably notice my bracelets here, and they are from Kanu, which is kind of my emotional home. This is the labour ward where we work, and the hospital is the Murtala Muhammad State Hospital. This was the neonatal unit, and they only had one incubator, and that was rubbish. And these are where the mums, basically after they've given birth, would go and queue up. They have a 1 hour time limit from giving birth to being stitched up and cleaned up, and then waiting for their husbands or for the fathers or for the uncles to come and collect them. And so it's not an ideal situation. You can imagine sepsis is very high. So what we do is that we go in and basically we buy resuscitators, we go in and buy incubators, and we try and support this. One of the things we try and do is to have a nod to sustainability and infrastructure support. We are not in the business of collecting data for the sake of collecting data. We go in and we build the labs, we build the NICUs, and we help the hospital collect their own data, and then they share that data with us. So they own that data, and then they share that data with us. And that is, quite frankly, a unique model, sadly, a unique model, which we're all too often experiencing. But it's a model of basically engagement with equal partnership. These are the labs that we build, and this is Aisha and Rashida, and I'll come back to her in a moment, and there's one of our team, Edward, building the labs. The one thing I will just say is that this particular lab that I'm going to go backwards. No, for some reason can't go backwards. But this particular lab that we did build in the back of the hospital, oh, there we go. This particular lab, we were sort of sharing the lab. As you can see, it's sort of built onto the back of the NICU. So the one thing that we're doing now is we're building actually a lab out of bricks and mortar, and we're putting that onto the side of the hospital, again, so we have sustainability and longevity. And that when we leave the study, which will be in about 3 years' time, that this structure will be always a permanent fixture, that will always be a clinical laboratory that will basically serve patient populations. We also do the very similar sort of stuff in Dhaka Medical College Hospital in Dhaka. This is the space that we were sort of inherited beforehand, and this is what it looks like after we came in and did laboratory refurbishment. So again, we put money and skin into the game, and we build up an infrastructure so that people can manage their own populations and then share the data with us. So that is in Bangladesh. And we've done the same in Pakistan. This is NICH in Karachi. You can see that the ceilings are falling down, and it's a bit of a mess. This was before. We went into partnership with the WHO, and this is what it looks like after. And so again, the whole idea is that we help them to manage their patient populations, and then they share the data with us. This slide is really important because the problem that you have, if we went into the Royal Hobart Hospital right here, right now, just down the road, and we looked at their microbiology lab, it would be superb. It would be full of automated equipment, and it would be just magnificent. The problem that you have in Africa is that those machines are pretty useless because electricity supply goes off most of the time, and so the machines will come crashing down. So how do you actually do clinical microbiology to look at sepsis? So essentially what we've done is to design really, really simple media through a company called Leofilchem, which is based on the east coast of Italy. And they produce these media and antibiotic discs at cost. And so we're able to put together a program that is fundable and sustainable in order to manage that. And the reason for that is very simple. Antibiotics are cheap. You might have not noticed it when the slide on that table, but they cost about $4 or $5 a day. Diagnostics cost about $20. So who's going to pay for the diagnostics? No one. No one. So what we need to do is to drive the cost of the diagnostics down almost below that of the cost of an antibiotic. $5 a day is the ceiling. And unless we get that right, we're not going to understand what is causing the infection. We're not going to be able to manage the patient. We're not going to be looking at outbreaks or how to manage outbreaks. So this kind of economic ceiling is really, really important. And so we're going sub $5, and we're trying to get companies on board to help us do that. And we have a group, a prize, and we're speaking to the World Bank at the moment about how we do that. This is just some of our team. I'll come on to this little fellow in a minute. But essentially, this is the labs that we built, and our team wearing our lab coats, the IOI lab coats, which we're very proud about. This is our team in Islamabad. This is Rida, who's doing a study on a baby like this. And this is our team in Kanu, at the MSS Kanu. And we also, by the way, this is Rashida at the front, we also help fund education programs in these hospitals or in the universities that are linked to the hospitals. So for example, Rashida is now doing an MSc, and that will actually help her to get involved in the study and to really be emotionally involved, but it also gives her a degree at the end of this, so then she can go on and build her career. And it's about stopping the brain drain, but also empowering people to go on and build their careers when they come in and work with us. This is kind of some of the offshoots of Program C. And basically, we have this huge clinical platform. And in the neonates alone, we will collect over 200,000 babies, of which we'll probably have about 30 to 40,000 septic cases. What we're doing phage trials in Brazil. We're looking at cost-effective interventions, fly screens, fly catchers, etc. We want to understand the morbidity associated with this. Very quickly, we had a journalist follow me out to Ethiopia. Her name is Bisma Khan. And we interviewed two mothers. Two of the mothers had term babies, two of the mothers had preterm. The preterm babies perished, but we didn't know that at the time. But Ms. Misbo was interviewing the mothers, and it's supposed to be a joyous time having a baby, and everybody's celebrating, but they're not. They're stuck in Desi Hospital with a very, very sick baby that has a 50% chance of dying or living. And there's a stigma attached to the mother with that. And we're trying to understand that sort of social stigma and what that actually means. We're trying to also now look at a gallery, a photo gallery that we will bring to the United Nations in New York in September to bring these stories of the babies and their mothers into the UN to make it real for people to understand the burden and mortality burden, at least, of AMR. We want to look at the effect of antibiotics, etc., on the gut of the baby and the development of the baby. Again, we're very interested in designing cost-effective diagnostics to alleviate the kind of the randomness or the Russian roulette of using antibiotics. We want to look at antibiotic drug levels correlated with clinical outcomes, and again, looking at insects. So this brings me on to my final part of my talk. And I don't know if you know this, probably not, but 2024 is a big, big year. And it's a big year because we all go to the United Nations and we talk about antimicrobial resistance. Happens every year, every September. There is a big United Nations meeting, usually to do with health, but not exclusively. And the last one was to do with vaccines. We did have one in 2016. And, so really sort of how did that go? So this is climate change. And this is Extinction Rebellion, and these are placards around the world every single time there is a COP. This is now King Charles. At the time, he was Prince Charles. This is not everybody's favorite politician, but nonetheless, he's speaking to David Attenborough, who everybody does like. So there has to be some credence in that. But nonetheless, this is something that politicians get involved in. But, the climate change bill, global one, Paris Agreement 2019, it took a long time to get going, as indeed the tobacco tax. And the thing is, we cannot wait that long. So this guy here, his name is Lord Jim O'Neill. He's a really, really good guy. He basically wrote this report, and he's wrote several reports, and that was done by the British government, and the British government were very proactive at that time. It was done by this guy, David Cameron. This was the Chancellor at the time, George Osborne. And this remarkable lady here is Dame Sally Davis, and she was like the champion of AMR, not just in UK, but actually globally. And then we have this sort of timeline that whittles down all the way to September 2016, where we had 193 sovereign states rock up and sign this particular document here. Did it work? No, it didn't work. Because people rocked up to New York, they signed a bit of paper, and they agreed to something called a National Action Plan. In other words, they go back and they implement X, Y, and Z. And did X, Y, and Z happen? No, because they couldn't afford X, Y, and Z. So who's going to afford X, Y, and Z? So the health economics around this were very, very bad. And so essentially what we now have here is that the 2023 meeting that was just gone was actually on vaccines. And this was really interesting, not in a good way, by the way. So essentially this was to bring essentially 193 sovereign states together, basically to talk about shortfall of health in terms of vaccines to nearly, well, over 500 million people. So did that work? No. So why didn't it work? Because again, there is this difference between high-income countries and low-income countries. This is the high-income country. US delegates expressed regret that language on sexual and reproductive health rights was not strengthened, a point echoed by the United Kingdom. In other words, there was this discussion about rights to abortion or rights to fertility, etc., etc. But actually, that's not what this particular meeting was about. It was about vaccines. So what did the Syrian representatives said? We cannot consider these declarations consensual if they leave a large part of the population behind. Algeria, gaps between the views of countries between North and South, and I'll come back to that point in a minute, and that negotiations place pressure on developing countries. Nicaragua's delegate said the proposals of the affected countries on the global South were once again ignored. In other words, you have this North-South divide. And we're in Tasmania, in fact, we are global South. But that's not what this refers to. It refers to global North and global South in terms of economics, which is really, really unhelpful. Hopefully So this is the compass. All of you have seen the compass. And this is North, and this is South. And North always sits usually above South. Not always, but usually it sits above South. So if the high-income countries are up here and low-income countries are down there, it's just really, really bad optics. And then when I was in a UK government meeting just before Christmas, they were talking about the Northern Star as a mission. It used to be the moonshot, and it's now the Northern Star. Well, how much of the population on planet Earth can see the Northern Star? Only in the Northern Hemisphere. So what stupid, why not call it Alpha Centauri or Alpha Cura, which is in the Southern Hemisphere? But no, everything has to be Northern Hemisphere. So the language in which we use is really, really unfortunate. And that, of course, segued to the breakdown with the vaccine, UN vaccine meeting. It was so bad that by day 3, nearly all the low-income countries, delegates, ministers, sovereign states, prime ministers had left because they just had enough. So we're in a bad place. And I was interested in basically asking a lot of my low-income country colleagues and friends what they wanted from the United Nations. They wanted antibiotic access, sustainable funding, diagnostic access, and infrastructure development. That's what they wanted. They didn't want research, etc. What they wanted to do was to basically get the basics right. So this is kind of where I come in with several colleagues, and the one I want to point out to is this guy here. His name is Michael Corley, just to the left of me there. And he and I are going around the world. We're meeting sovereign state heads, prime ministers, etc. So this guy here, his name is Ali Patti, and he is the Minister of Health for Nigeria. This lady here, I don't know if you know her in the room, she's the Prime Minister of Bangladesh. Her name is Sheikh Hasina, and I met with her, and we had lots of conversations, and I will go back and meet with her again in the middle of May. And importantly, we've been meeting with the embassy, London embassy staff here in the Chinese embassy. Why is this important? Because every single person, more or less, that has some sort of putting together some sort of UN delegate body seems to be leaving out China. And that is completely and utterly insane. And it doesn't matter what we might think of China with the stamp down in Hong Kong or what goes on in Taiwan. China has to be part of the solution. It cannot just always be part of the problem. China produces 60% of the world's antibiotics that's used in agriculture. It produces about 48% of the world's total antibiotics. And China will also provide the solutions to diagnostics, cost-effective diagnostics. So China has to be part of the solution. And that is why straight after I leave Tasmania, I will be flying into China to meet with various Chinese government officials, and we are the first people to go and meet them, as incredible as it sounds, and we want to encourage them to come to September to the UN meeting and tell us what they want. In terms of communication, Antibiotic Armageddon, if that sounds familiar, we've also tried to reach out to teenagers. So we produced this anime film. This is scene 1. This guy here dies. Bit of a spoiler alert there if you're going to go and watch it. And this is scene 2. And this goes on for 5 minutes. I won't digress because we're running out of time. But the whole idea of this is to use every single form that we possibly can to reach various groups in societies across the world to make sure that we get the message across in terms of public health. I think this is my team now. This is the biology team in Oxford. You'll notice 3 things here. Number 1, over 80% of my team are women. So we're having a positive employment campaign for men, just to let you know. So if you're a guy in the audience, you want to come to Oxford, rock up, that's good. Second thing to note is that you'll notice this, and we come from all parts of the planet, and we're incredibly multicultural, and that is just the way we want to be. And you'll notice that the really important people are at the front, and the really useless, irrelevant ones, like this guy here, is at the back. This is just some of our international team where we had a meeting in London, and this is about half of our PIs. So we employ or engage about over 350, nearly 400 people across Africa and Pakistan and Bangladesh. And again, it's about helping them to basically build careers on the back of the data that we supply from the infrastructure we do. Finally, nearly finally, I just got to thank 2 people in particular. The first one is basically my sister, who passed away nearly 4 years ago now. And she was very much fundamental and instrumental in helping me settle down in Tasmania and not to be so much of an angry young man. And she had a profound impact on my life that I'll take to the grave with me. The second one is my dear wife, who's sitting over there. And I'm all over the place, and I'm a bit mad. And therefore, there has to be a bit of a yin and a yang in the family, to use a Chinese expression. And so Catherine is, the stability in all of this, and has to endure my madness and patience of a saint. So thank you very much for, and we're nearly coming up to 40 years of going out with each other as of April the 20th, when we had our first kiss just out St. David's in Hobart. That's just to say thank you very much for listening, for not falling apart, falling asleep, in all the languages that we use around the world and in the countries where we work. So thank you.
Thank you, Tim. Wonderful talk, and really some work that really exemplifies the values that we try and instill in our students.
Thanks. Thank you for that really inspiring talk. It was just terrific, if a little depressing. I went to another really terrific talk by an Englishman a month or so ago. It was at Science in the Pub. Marvellous group of people who organise these events. And it was an academic from UTAS who works at the Institute of Agriculture. And he was telling us that we shouldn't be killing flies, that flies were really important and to the whole global pollination scene, and that we, honeybees were only just a very minor part of that whole international pattern that was keeping us alive. We're not really going to be able to get rid of all the flies anyhow. And so were you being serious when you said, don't kill the flies? We were doing good for humanity by kill the flies, that was a good move?
Well, number one is I have a pathological hatred for flies, so I'm slightly biased. And number two is that unquestionably in some parts of the world, they are vectors for transmitting bacteria. And the reason why we did this study was because many years ago, I was in the civil hospital, which is in Karachi in Pakistan. And I saw the same fly go from one infant to another, to another, to another. And I thought, this is insane. So look, if you have a hospital where you're closed off to the elements and good infection control is present, then sure, you can be merciful to your flies. But generally speaking, I think if they're anywhere near the hospital or in the hospital, please feel free to obliterate them at your heart's content.
Tim, we do have a question online. So Vicky asks, what do you think regarding our diets? So silly question maybe, she says, but probably not. What do you think about its diets? And its
I'm
problems
probably the last
in
person
relation
to ask about diets, but one of the things that we're doing is trying to understand the effect of the diet on the development of the baby. And so what we're doing we've got two studies, one in Kano and one in Islamabad, and we're taking infants and we're taking them from day 0 all the way up to 2 years. And we're looking at the development of their microbiota, in other words, their gut organisms, and the development of that, the effect of antibiotics, the effect of breast milk, the effect of powdered milk, etc. And unquestionably, our gut microbiota has a profound effect on us, both in terms of general health, but also emotional and also mental health and well-being. And that is only starting to come to the fore. And so, I think this has been an explosion in studies in about the last 5 years on this. And, I think if you can afford, and this is a really important point, if you can afford a good, healthy diet and a balanced diet, then that is the thing to do. Whether you're omnivore, whether you're vegan or vegetarian, and I don't necessarily subscribe to any of those, but having a well-balanced diet unquestionably helps mental health.
Thank you very much for your talk, Professor Walsh. I am interested in your discussion around salmon. In Tasmania, we have controversially salmon industry in our marine waterways, and I'm a bit of an activist in this area. I have highlighted the use of antibiotics here. You allude to the fact that we don't use a lot, but we use tons. And I've been reading about shorebirds and the vector transfer of antibiotic resistance around that in Patagonia in particular. And I wondered if you could comment if there's any research that you're aware of in this area and what implications that has for our marine life, given that they're now finding native fish 7 months after antibiotic treatment in Tasmania with antibiotic levels higher than what we accept in Europe.
Yes, I'm not an expert in fisheries, but I'll try and get the basis or outline the basis. I know that I think it's Tazol that they use tetracycline in salmon farms. The problem when you use any antibiotic is let's say you use antibiotic A and you think you're selecting for resistance A, but you're not. When you use antibiotic A, you're selecting for resistance to A, B, C, and D, because the genes often gather together, they cluster together. I gave an example on plasmids, but it's a lot more complicated than that. And so if you can go to programs like vaccination and remove antibiotics, then you remove that risk. What you will unquestionably start to confer resistance in the salmon population, or the bacteria within the salmon population, the E. coli and the Salmonella and the Aeromonas, which I guess are the main culprits here. And the question is, do they spread to other wildlife, or then do you ingest them as human beings, and what is the impact of that? And there's variations throughout all of that. But unquestionably, if we can use other methods and remove antibiotics, we just don't remove resistance, as I said, to A, but also B, C, and D, because these genes come along with their friends.
And we have time for one more question. Back to Tim.
Hi, Tim. Oh, yeah, volume's good. This is sort of piggybacking off the first question, and that was an amazing talk, by the way. But you had in one of your graphs that there was a link between AMR and environmental pollution, and that you saw like lots of AMR and like a high plasmid turnover in these high plastic environments. I was just wondering if you had any thoughts on why that might be. So like, is it like the temperature? Are there more insects in this environment? Yeah.
So we the reason why I was nebulous is not because I'm normally nebulous, although I am, but actually we haven't published that data yet. So I kind of just gave you a taster. And we know the gene involved that is activated. And so the presence of the plastics actually switches on and switches off genes in the bacteria, which enables them to transfer the plasmids more rapidly and against a greater number of species. So it's actually the presence of the plastics and how the bacteria are exposed to them that makes them more, if you like, makes AMR spread in terms of being more permissive. But we know the gene, and I'm happy to send you the paper if we ever get it published.
Thanks, Tim. So unfortunately, we've run out of time for further questions, but I'm sure there'll be further conversations amongst us all tonight and tomorrow. Before we conclude our evening, I'd like to invite the Vice-Chancellor, Professor Rufus Black, to present Professor Tim Walsh with the 2023 Distinguished Alumni Award.
So it's a real honour to be able to be presenting Professor Tim Walsh with this Distinguished Alumni Award. I think tonight he told his own story. It's not any need to embellish it at all. He told his own story in a beautiful and powerful way that I think we all found moving, inspiring, challenging as well. The University of Tasmania, when it awards its Distinguished Alumni Awards, looks around its remarkable alumni across the globe. And in the fields of sort of medical science and medical research, we have a great many. It's one of the things that we've, as a university, produced very large numbers of, not just here in Tasmania, but people who have careers with great impact around the world. As a university, we're deeply committed to tackling global problems and confronting global challenges. The Sustainable Development Goals guide and inspire us, and in the way that universities get ranked, overall we get ranked number 5 in the world for our commitment and delivery against those. Number 1 in the world in climate action. So one of the things we look for is people who are making differences against those kind of global challenges and who put the values and vision that lie at those, with those goals at their heart. And Tim obviously does that in the most extraordinary way. We're also, as a university, passionate about ensuring that interdisciplinary work that spans different kinds of academic work that enables great impact to happen. And tonight, we saw both medical science and economics brought together in brilliant and creative ways that enable that kind of impact to be delivered. Again, we saw that just so richly and deeply. And we recognise that one of the ways the world will need to change is when the whole system changes, is when we recognise that our global and local systems have to undergo profound change. And here we saw one of the most fantastic expositions I think you'll see anywhere in the academic world of the capacity to think about global systems and the kinds of ways we need to intervene in them in order to see better outcomes for people across the planet. It was such a rich and powerful vision of that. But I think the thing that told most deeply was that picture at the end. Tim's personal commitment to values of diversity, inclusion, of global commitment to people isn't just something that happens out there in the field, it happens there in his own lab. And I think one of the ways that we want to know our alumni by is the deeply authentic ways in which they live their values and their vision. And tonight, in virtually every slide and every story that Tim had to tell, that was deeply apparent. And it's an inspiration to us all to be able to try and live our own academic, professional and university lives in those ways. Because when we give an award like this, I hope that those who receive it feel recognised, but in lots of ways what it does for us, hold up people who we want to be like, who we want to inspire us, whose work we want to be able to follow, so that we too can actually start to contribute to the kinds of efforts that people like Tim show the way on. So Tim, on behalf of the university, it is an enormous pleasure and a privilege for us to be awarding you our Distinguished Alumni Award.
Well, thank you very much for staying awake throughout my lecture. It's always a challenge. And thank you very much for this award. It's very interesting because when you listen to me, you think I'm just a POM. But when I'm back in Oxford, every now and again, some Australian does slip out. And I'm reminded, after a few pints down the local pub, where I spent 15 years of my life. I made the comment that, and it's a very serious one, that when I came to Tasmania, Tasmania gave me a reset, gave me the opportunity to kind of space, if you like, to develop. If I'd stayed in the UK, in the schooling system in the UK, there's absolutely no way that I would be where I am now. And so that was really, of huge importance to me. And in fact, we were talking about some colleagues like, for example, Tom Ross. And Tom was doing a PhD. And I had no idea what a PhD was. What is a PhD? Why would you want to do a PhD? And then I decided to go on and do a PhD, and I started to apply in the UK. And I was very fortunate to do a PhD. The only reason why Bristol took me to do a PhD was because I'd done my postgraduate diploma, here in Hobart. So Hobart has been a fundamental part of that journey. And I certainly wouldn't be where I am now in one of a decent university in the UK, let's just call it that for the time being, without that sort of grounding that I had in Tasmania. And not only that, but I also appreciated, got involved when I was a university student here with the TURDS. For those of you who don't know what the TURDS are, Tasmanian University Rubber Ducky Society, way back in 1983, no dams, Franklin River, etc. And so I, started to appreciate kind of the wilderness, the environment around you, and how precious it is as well. And so all of those things made a huge impact on my life, clearly. So anyway, look, thank you ever so much for this award, and thank you for the 15 years that I spent in Tasmania, because clearly the impact was immense in my life, so thank you.
Thank you, Rufus, and please join me a final time in thanking our speaker, Professor Tim Walsh. And if anyone doesn't collect your fly box, we'll make sure we find a student at the university. Yeah, you've got one? All right. Yeah. So I would also like to extend my gratitude on behalf of the university and the Tasmanian School of Medicine to the Arthur Cobbold Memorial Committee members for their work on the series over the last decade. Without their dedication, events like this just simply wouldn't happen. And finally, in particular, I would also like to thank each of you who have joined us for this important conversation. Together, whether you work in health-related fields or not, we have an opportunity to each make small changes, have small but informed conversations, and united in our mission, we might just make a big difference like Tim has in our community. So thank you for taking part in this special event. On behalf of the University of Tasmania, have a happy and safe evening, and good night.